Hello everyone, this is the video lecture for Pre-Calculus Chapter 3.5. So, if you watch 3.4, there was one time on one little mention problem that I didn't actually do it, and it said, look out, there's going to be rational and irrational problems, or whatever on it. And I thought, did I mean imaginary? I did not mean imaginary because this is the section for imaginary numbers. Okay, so here we go. As you know, hopefully, I is equal to the square root of -1. I squared is equal to -1. These are super important, and we'll be using them throughout the rest of this section for sure. So let's get started. I mean, there's really nothing else to talk about besides that, so... 35010, we got p of x is equal to x cubed plus 3x squared plus 3x. That's a lot of 3's and x's. Find the zeros. I mean, that's really all this is. Find your zeros. X equals what? And so we're expecting imaginary numbers now. Go figure. So I'm going to factor out an x. That's pretty easy. And so you can see right here that we got x equals 0. That's one of my answers. Whenever you have x just by itself, that means x equals 0. And whenever you got a confusing quadratic form, use quadratic formula to be able to figure this thing out. So here we go, -3 plus or minus the square root of 3 squared minus 4 times 1 times 3, all divided by 2 times 1. Doing some math, we've got -3 plus or minus the square root of 9 minus 12. You see a problem here? And so what we have is a -3 inside. Well, here's the point. Whenever we have a negative inside of the square root, all we have to do is type an I on the outside, and then we're good. That's it. We're done. That's the remaining answers. So if they had said x equals what? Well, I would put 0, and then -3 plus I square root of 3 all over 2, and -3 minus I square root of 3 all over 2. Okay. That's good enough. Or again, you could maybe use the plus and minus button if there is one available. At the very end, they're wanting the factored form of this. And I don't think that WebAssign's very picky, but this one was very strange to me. Let me just type out what I have here as the answer, because it's quite strange. First off, x. And then I got x minus -3 plus I square root of 3 all over 2. And then x minus a -3 minus I square root of 3 all over 2. This whole chunk here is one big fraction. I'm just making it look kind of silly, I guess. I'm not exactly sure if WebAssign will take something a little less intricate than that. But I have that boxed in. Apparently that was a good answer. So there you go. You got something. Could they, like, take something like this? I mean, that's kind of technically factored form. I don't know. I would try it. I mean, just if you're just goofing around trying it, why not? Okay, so that thing works. The main thing, just notice that this is the only thing that's really changing. You're always going to say x minus blah, x minus blah, whatever you have in there. Here, this is x minus 0 technically, right? So you'll always have the x minus, and then you put the number. So just, you know, everything else is just changing to that number that you need. 35013. So again, p of x is equal to x to the 4th minus 256. Same thing, solve for x, factored form, etc. Okay. So what... Oh, not 0. Box. What I see is that this is something like a perfect square kind of thing. And so I actually factored this x squared minus the 16, x squared plus the 16. And you can factor these guys down. This one's super easy. He's minus 4 plus 4. This guy's actually kind of interesting. Can you factor that down further? And initially you say no. But what if you went and solved for x Can you see what the answers are without even doing it? It's plus or minus 4i. Basically, you have that plus in with a perfect square there. It just changes it to i's instead of regular old plus and minus 4. And so I'm getting the point is what I'm saying. You could just replace it. You could factor this as the same thing you had over here, plus or minus 4, but this time you're just attaching an I to them. And so those are your answers. This is your factored form, by the way, if you want to get your answers for negative 4, 4i, negative 4i, and now everyone is happy. So there you go. Okay. Next problem. 35034. So I've got p of x equal to x to the 5th plus 10x cubed. Same instructions. Find the zeros, factored form, whatever. Well, I can see that x cubed can get factored out of that immediately. So let's just pause here on this. This is a super easy answer at this point. If this guy turned into this, right? Here's another example. What if we had this guy? Wouldn't I just get plus or minus 3i? Right? 9 goes to 3. Here's another example. What if I had plus 25? Well, you already guessed it, right? It's 5, right? Plus or minus 5. So then what do we do with 10? What is the square root of 10? And actually, there's nothing. It's just square root of 10. Ha! That was it. It's kind of a joke. But you can still factor it, although it might look a little weird. It's plus and minus I square root of 10. Now, remember, WebAssign is not picky. You don't have to write 3 right here. You can actually say plus or minus I square root of 9, and it will still accept it. Because what's the square root of 9? It's 3. It knows that. It's smart enough to understand that. So, similar with the 10, just say square root of 10. It's a decimal. I don't really know what it is, but there you go. That's your factored form. If you want to find the zeros, it's super easy now. So x equals 0. Multiplicity 3 if they're ever asking. I don't know. And then these guys, we already talked about them. We got plus or minus I square root of 10. And that's the answer. So you're not going to write the multiplicity in there. I'm pretty sure that they'll accept it without it. So, like, don't write mole 3. They won't understand mole 3. I'm just trying to clarify math-wise, I guess. It's hard because I want to give you the full answer math-wise, but WebAssign wants it a very particular way. So, like, whenever I say multiplicity stuff, they're not asking for multiplicity. They don't care at all. But I want to tell you because it makes sense. That's why there's a 3 right there. It's just multiplicity 3. That's what's going on. So the next question, they say q of x is equal to box, has a degree of 3, and it has some zeros. They give me some zeros. Here we go. You ready? 2, 4i, negative 4i. Those are my zeros. Okay. Well, let's do some math then, I guess. Well, x is equal to 2. X is equal to 4i. And x is equal to negative 4i. Okay. Those are my roots. Those are my zeros. But could I actually replace those with factors? Like, say, x minus 2, x minus 4i, and x plus 4i. Remember, it's always x minus something. Well, minus a negative here makes it a positive. So I'm just kind of doing one small step in the middle there. Multiply, multiply, multiply. There's your factors. I don't know if WebAssign would take this. That would be kind of funny if they did. You could try it. But I'm going to simplify it just a tiny bit. These guys right here actually combine together really simply. So x minus 2. These guys here together make x squared plus 16. Notice that 4 times 4 is 16. Very simple. But instead of putting the normal minus, you're putting a plus because of the i's. Again, this is all review. I'm kind of assuming some of this is a review for you, especially here in the imaginary stuff. But I know I'm going a little fast. That's why you can hit the pause button. That's why you can ask me questions. I think you can even slow down the speed, maybe if you want me to talk slowly. So, FOIL this thing out. I got x cubed plus 16x minus 2x squared minus 32, and this aggravates me. So I'm going to rewrite it a little better. Okay, there you go. 35048. So P of x is equal to x cubed minus 9x squared plus 25x minus 25. They say, go, figure it out. And I can't see a good way to get the answers here on this without a calculator, unless we do the possible rational zeros. Now, factors of 25 are not too bad. 1, 5, and 25, I guess that's it. Factors of the 1 in the front right there, just a 1. Extra 1 right there. Well, that's super easy. It's not too many questions or too many options. So let's start synthetic division. And hopefully I can get something that works pretty fast. 1, negative 8, negative 8. I don't know what this is, but it's not going to work. Honestly, it's not going to work. So, whatever. I could use a calculator, but it's not worth it now. And it's good for you to be able to see that as well, you know. It's not always just numeric. It's like concept and understanding. Like, I don't know, just random example here. Say like, oh, you know, your bill at Walmart is $32 or something, and you hand them a $100 bill, let's say, and then you only get back 50. You're like, there's something wrong here, isn't there? You know, you don't have to do all the math to know that I think I need more. So, anyways, moving on. So negative 1, negative 10, positive 10. That's actually a 35, and this is not going to work. Trying another one. 5. Again, just listing it out. 1, 5, and 25 are pretty much the only numbers that'll work here. Hopefully. So we got 5, negative 4. It's going to be a negative 20. Makes a 5, 25, 0. Cool. So x equals 5. It's one of my answers. What we get out of this is x squared minus 4x plus 5 equals 0. Now I'm going to ask you, can you factor this? And you might think, well, yeah, it's 5 and 1. Right? That's how you get the 4. You go positive, negative 5 and plus 1. Right? Negative 5 and a plus 1. Well, yeah, but when you multiply these two guys together, you get a negative 5. You got a positive 5 here. That doesn't work. This actually is not, it's close, but it's not right. What I'm going to do is quadratic formula. Oh, not that again. Yep, that again. So, x equals a negative, or, yeah, negative 4 plus or minus the square root of negative 4 squared minus 4 times the 1 times the positive 5, all divided by 2 times 1. Remember what section we're in. We're in imaginary numbers, right? So wouldn't you imagine, that you would get imaginary numbers? Oh, that was so bad. Well, you know, you can't tell me anything, I guess, since it's a recording. Then I get like 100 emails. Your jokes are so punny. So we got an I. And of course, square root of 4 is a 2. So, yeah, just 2i is fine. Notice that everything's got a 2. You can cancel that. So 4 and 2, 2 and 2 cancels, makes a 2 plus or minus I. And those are your last answers. So, I mean, if they're wanting, a final answer like a list, which I think is what they're wanting here, 5, 2 plus I, 2 minus I. And there you go. That's it. Got one last question. It's actually a little bit shorter section, at least for me. Sometimes that makes me think if there was just a whole ton of repeats, you know. And they do that sometimes on your homework. Kind of gets annoying. Okay. There we go. Find the zeros, factored form. Ooh, two different factored forms. Well, we'll talk about it when we get there. So, possible rational zeros. Here we got factors of 36, divided by factors of 1, so it's not going to be a big deal. 1, 2, I'm sure there's a 3 in there, surely a 6. I didn't actually list out what these are. Apparently I got lazy. And some other numbers. Okay. You're not going to... If we need more than that, then surely there's going to be something going on. So let's just start with the basic numbers. I always start with 1. Now notice this is x to the 4th. Where's your x cubed? Ooh, you need a placeholder. X squared. Where's your regular x? Ooh, you need a placeholder. You need a 0 there. Now, as you've seen me with synthetic division, I don't always write these on the top. I do that more so in the algebra class because I try to like remember what powers there were and all that stuff. But here, PreCal, we've seen it a couple times. It's not a big deal. I do this specifically because we're missing components, and I want to just remind you, the whole sequence of that, okay? 1 times 1 is 1, plus 0 is 1. 1 times 1 is 1. We got a 6 now. 6, 6, 6, and not a 0. Okay, let's try some more numbers. Surely something will work, quickly here. -1, 2 negatives make a +1. -6, +6, and it didn't work. What was the next number? 2? We could do a 2. Again, you could use a calculator to get some of this. But I'm going to ask you, would Desmos give you complex imaginary numbers? And I'm going to say no. Pretty sure it doesn't. So, unless there's something that I don't know, it's a good skill to be doing what we're doing here, okay? 2 times 18 is 36 indeed, so we're good. So x equals 2, that's one of them. Notice that we have this crazy huge answer. This was, again, x to the 4th. Now this is x cubed. We're not at the point at which I can actually... quadratic formula or something like that, So I'm going to go another one. I'm going to try -2 now, but with these new numbers. So you notice that I'm using these guys right here because I don't want to retry the same numbers. I would get nowhere, but this here we're starting to reduce it down some, and hopefully we get something here. Notice that we got a 0, and anything times 0 is 0. It's kind of a strange one. We don't often get that. And then we got 9... -18. Aha! We got it. Cool. So x equals -2 is also an answer. Notice what we got here. This was an x cubed. Now this is an x squared. So 1x squared plus 9 equals 0. Come on. We got this. We're trying to find the imaginary numbers, right? What are they? Plus or minus 3i. Again, just square root of 9 is 3. Ta-da! So, big list. Here we go. Big list. We got 2, -2, and then there's not like a number in the front. Sometimes we do have it, but it's a 3i and a -3i. There's my big list. So there's two different parts at the very bottom here. They got factored real coefficients. Factored real coefficients. Whatever that means. Let me just give you the answer, and then you'll be like, oh yeah. X minus 2, x plus 2, and then x squared plus 9. Notice that we're not wanting i's in our answer. We're wanting the step above the i's in our answer, okay? And these guys, again, just came from x equals 2 and x equals a -2. 2 negatives make a positive, that kind of thing. They also want the factored with complex numbers. When they say complex, they're meaning imaginary. There's a big scheme on how they're not really the same, but I'm just saying whenever you see complex, imaginary, that I can't spell it right, but you get the point. They're wanting i's. That's what they're wanting. They're saying, yes, i's are good. So you just do the same thing. X minus 2, x plus 2. And then remember that this right here, this is x equals 3i. So when I'm moving this over, it's going to be x minus 3i, okay? And then this is -3, x equals a -3i. when I add it, when I move it to the other side, it's now going to be an x plus 3i, okay? Cool. That's your final answer there. And we're done. That was an easy section. Thank you very much. Have a great day.